Hello everyone, myself Dr. M. Pavan Kumar Reddy, Assistant Professor, Department of Mathematics, VNR VJEC. Today our topic is applications of multiple integrals, area and volume. How to find area and volume using double and triple integrals, we'll see. First, area using double integrals. So consider the area, the region is bounded by the curves y is equals to f of x, y is equals to g of x is equals to a, x is equals to b. In the xy plane, the region is bounded by y is equals to f of x and g of x, two curves, x equals to a, x equals to b. That means y limits are functions of x limits are constants. A and b are here constants, f and g are functions of x. So the region is bounded by these curves. So in such case, the area A is equal, area is denoted by A, double integral over the region R dy dx. Here we don't have any integrand. Okay, integrand is 1. We are finding area means integrand is 1. Even in case of volume also, we are finding in volume means integrand is 1. So which is equals to, since y limits are functions of x, so that first we integrate with respect to y and next we integrate with respect to x. Okay, this is one case. Suppose the region may be bounded by the curves f of y, g of y, where f and g are functions of y, that is x limits are functions of y limits are constant, say a and b, also in xy plane. In such case, the area is double integral dx dy. Since here x limits are functions of y, first we integrate with respect to x, next with respect to y. Okay, see, and this is the evaluation using double integrals, area using double integrals in Cartesian coordinates. Now finding area in polar coordinates. Suppose if the region R is represented through polar coordinates, then the area is given by A is equals to double integral over the region R dr d theta. As we studied that while transforming from one coordinate system to another coordinate system, we'll take dx dy is equals to Jacobian of dr into d theta. That is Jacobian in case of two variables x, y, Jacobian with respect to r and theta is r, as we know. So now double integral r dr d theta. So dx, instead of dx dy in Cartesian coordinates, here in polar coordinates we get r dr d theta. So a is equals to double integral over r dr d theta. Of course, r is a functions of theta and theta limits are constants. This is formula to determine area. Let's see. This is volume. Now let's see the volume V enclosed by the surface S. The volume V enclosed by the surface S. Then the volume in Cartesian coordinates V is equals to triple integral over the volume V dx dy dz. See here integrand is 1. Here integrand is 1. Triple integral over V dx dy dz. Whereas in case of cylindrical polar coordinates, the volume is given by triple integral over V r dr d theta dz. R dr d theta dz. Similar manner, in spherical polar coordinates, the volume is given by triple integral over the region over the volume V r square sine theta dr d theta d pi. So these are the formulae to determine the volume using triple integral. Let's evaluate problems. See, evaluate the area enclosed by the parabolas x square is equals to y and y square is equals to x. See, both are parabola. X square equals to y parabola is a symmetric about y axis, and y square equals to x parabola is symmetric about x axis. See here, this is the parabola. Y square is equals to x. This is, and this is the parabola x square is equals to y. This y square equal to x is symmetric about x axis, and x square equals to y is symmetric about y axis. Okay, so these two, the common region, see the region is bounded by these two parabolas. So the common region to the two parabolas is, see this is the common region. Observe here, this is the common region. This is the common region. Okay. So now to evaluate a double integral, okay, we generally consider a vertical strip or horizontal strip in the region, and we identify the corresponding limits and we evaluate. So first, what is the formula to determine area? See, area is equals to, it is double integral over the region R. Okay, it is dx into dy, dx into dy. See here, the region is bounded by these two parabolas. See, this is one parabola, this is another parabola. Okay, and now let's determine the intersection points of these parabola. Of course, these two parabolas are intersecting at origin and also at this point. So this point will determine, by substituting one equation into the other, we'll get the intersection point. See, put y is equals to x square in y square is equals to x. That is, x to the power of 4 is equals to x, which is x power 4 minus x is equals to 0, which is x into x cube minus 1 is equals to 0. That is, either x is equals to 0 or x cube minus 1 is equals to 0. So which is in the form of a cube minus b cube, a minus b into a square plus ab plus b square. Okay, anyway, we'll consider only x minus 1 factor. So that is x is equals to 0. Since the other factor x square plus x plus 1 is equals to 0 roots are complex, we ignore those. So only these are, so x is equal to 0 and x equals to 1. So now when x equals to 0, what is the corresponding value for y? Let's substitute this x equal to 0 and y equal to x square. So now when x is equals to 0, the corresponding value for y is obviously 0. And when x is equals to 1, the corresponding value for y is y equals to x square. 1 square is 1. That means that these two parabolas intersect at origin and at the point 1, 1. That means that this is the line x is equals to 1 and this is the line y is equals to 1. Okay, of course, this is x-axis y0. This is y-axis x0. Okay, now identifying the limits. Let's consider either vertical or horizontal strip. Your wish. Either one we can consider. So here I am considering horizontal strip in the region. See, horizontal strip means x limits are functions of y. So where the strip has its ends, left end of the strip is moving on y square equal to x. That means x equals to y square. We take it is x equals to y square. We have to write, we have to express x in terms of y. So x equal to y square. See, right end of the strip is moving on x square equal to y. So you have to write this x equals to root y. That means that here, see, integral limits are c. So by considering horizontal strip, so that x varies from y square to root over y. Since left end of the strip is moving on y square equal to x, right end of the strip is moving on x square equal to y. Express both of them x in terms of y. That is x equals to y square and x equals to root over y. Now, to cover this region, this strip has to slide from the line y is equals to 0 to y is equals to 1 once. See here, this is the line y equals to 0 to up to this point y is equals to 1. So that is y varies from 0 to 1. Now we obtain the integral limits. Let's evaluate the integral. So therefore, area A is equals to integral double integral over the region R dx into dy, which is equivalent to integral. Here y limits are constant, so y varies from 0 to 1 and x varies from y square to root over y. Since x limits are functions of y, so first we have to integrate with respect to x and then with respect to y. Now integrate. First with respect to y now, there is no integrand. Integral y varies from 0 to 1. First with respect to x. So integral 1 into dx. Integral 1 dx is x only. Integral 1 dx is x. Upper limit is y, sorry, root y, and lower limit is y square into dy. Let's substitute the limits. Okay. that is, this is equals to integral y varies from 0 to 1. Let's substitute the limits. What is that? Root y minus y square. So upper limit is root y and substituting lower limit, so minus instead of x y square into dy. Now this is equals to. Now integrating with respect to y. See, root y integral is, it is y to the power of 1 by 2 we can write. Okay, y to the power of 1 by 2. That means it is y to the power of 1 by 2 plus 1 divided by 1 by 2 plus 1. Okay, minus y square integral is y cube divided by 3. Upper limit is 1 and lower limit is 0. This is equals to. Now, instead of y, we have to substitute 1 and 0. So, instead of y, if you substitute 1 to the power of anything is 1. So, 1 divided by 1 by 2 plus 1 is 3 by 2. Minus, instead of y1, so it is 1 by 3. Substitution of lower limit, that is minus. Here it is y equals 0, y equals 0. So, therefore, no contribution of lower limit. This is the reciprocal of 3 by 2 is 2 by 3 minus 1 by 3. 2 by 3 minus 1 by 3 is 1 by 3. So, therefore, the area bounded by the two parabolas is 1 by 3 units. Since this is the area bounded by these two parabolas is 1 by 3 units. Okay. Let's. Now, we'll see a problem in polar coordinates. Finding area in polar coordinates. See, find the area of the cardioid r is equals to a into 1 minus cos theta. We are familiar with this figure already. R equals to a into 1 minus cos theta. So, this is the cardioid. This is the cardioid. See here, this is x-axis, y-axis. In case of polar coordinates, what is r? R represents the distance of the point on the curve from the pole, and theta represent the angle made by that particular line with the positive direction of x-axis. So this is the cardioid. This is the cardioid. In this region, we consider a strip in the region which starts at pole, and we take a strip onto the curve. We strip onto the curve. That means that lower end of the strip is moving at r is equals to 0, which is pole. Lower end of the strip is moving at pole, and other end of the strip is moving at on the cardioid. So therefore r is equals to, it is a into 1 minus cos theta. So these are the limits for r. So to cover the region, this strip has to slide from the line theta is equal 0. What is the meaning of theta equal 0? Which is initial line. X-axis itself is initial line. Nothing but x-axis making an angle of 0 degrees with itself. That is theta equals to 0. So theta is equals to 0. Since you have reason here also, no. So that is theta is equal 0 to, see here, theta is equal 0 to 2 pi. But instead of taking theta is equal to 2 pi, we'll take only 0, theta equals to 0 to pi only, because this cardioid is symmetric about the initial line. This cardioid is symmetric about the initial line. So instead of evaluating throughout the region, it is enough to evaluate 2 times the area above the initial line. Okay, since it is symmetric, area above the initial line and below the initial line is same. Therefore, see here, see, we consider the limits. R varies. First, what is the area in polar coordinates? Area A is equals to double integral over the region R. It is r dr d theta. R dr d theta. So here R varies from, R varies from, one second, we'll do, this is since the curve is, cardioid is symmetric about the initial line. Since the, I'll write that statement. Since the cardioid is symmetric about the initial line, theta is equals to 0. So therefore, area is equals to 2 times double integral over area above the initial line. Above the initial line. Here the region is only we consider above the initial line into r dr d theta. So for this region, the limits for r are, r varies from 0 to a into 1 minus cos theta, and theta varies from 0 to pi. Since above the initial line, theta is equals to 0 to, theta is equals to, see here, theta is equals to 0 to, theta is equals to pi only. Okay, so these are the limits. Now substitute the limits, that is 2 into integral theta varies from 0 to pi and r varies from 0 to a into 1 minus cos theta r dr d theta. R dr d theta. Now first, since r limits are functions of theta, so first we integrate with respect to r. So theta varies from 0 to pi. What is integral r dr? R square divided by 2. Okay. Upper limit is a into 1 minus cos theta. Lower limit is 0 into d theta. Let's substitute the limits. What is upper limit? This is equals to 2 into integral theta varies from 0 to pi. See, and let's write this 2 outside. See, here we have 2, no? This 2 I am writing outside, so r square only. Now, instead of r square, upper limit is a into 1 minus cos theta whole square. Can be written as a square into 1 minus cos theta whole square. Upper limit, substitution of lower limit, which is 0. So, therefore, no contribution into d theta. Of course, this 2 and 2 gets cancelled. Okay. Therefore, now it is, let's simplify. A square is constant, can be written outside. Theta varies from 0 to pi. And see, it is 1 minus cos theta whole square. 1 minus cos theta whole square. 1 minus cos theta can be written as trigonometric formula. Okay. 1 minus cos, actually 1 minus cos 2 theta by 2. 1 minus cos 2 theta by 2 is, it is sine square theta. Sine square theta can be written as 1 minus cos 2 theta by 2. Okay. That means if it is 1 minus cos theta by 2 means it is sine square theta by 2. Here theta, here 2 theta we have. Here theta, so here it should be theta by 2. Sine square theta by 2. So we need 1 minus cos theta. So therefore 1 minus cos theta is equals to, it is 2 sine square theta by 2. Let's substitute here. It is 2 sine square theta by 2 whole square, which means it is 4 sine to the power of 4 theta by 2. 4 sine square. 2 sine square theta by 2 whole square. That is 4 sine power 4 theta by 2 into d theta. Okay. Okay. And of course, see here. Limits. Okay. Sorry. Theta varies from 0 to pi. 4 sine power 4 theta by 2 into d theta. Now, in order to evaluate this integral, see, let's take a substitution. Theta by 2 equals to, say, some t. Let's take the substitution. Theta by 2 is equals to, say, some t. In this case, then what is theta? Theta equals to 2t. And if you differentiate, what we get? D theta equals to 2 into dt. What are the limits for t now? When theta is equals to, if you take 0, the corresponding value for t also 0. When theta equals to pi, if you take, the corresponding value for t is, if you substitute pi here, theta equals to, you get t is equals to pi by 2. Let's substitute this. Therefore, area is equals to a square integral t varies from 0 to pi by 2. Of course, this 4 is also constant now, which can be written outside of the integral. And sine to the power of 4. What is theta by 2? Theta by 2 is t. Into what is d theta? D theta equals to 2 into dt. 2 into dt. So that therefore, this is equals to 4 into a square. 2 also, let's take outside. So therefore, it becomes 4 2 ja 8. It is 4 2 ja 8. So 4 2 ja 8. Integral t varies from 0 to pi by 2. It is sine to the power of 4t into dt. Into dt. We have a direct formula for this. What is that? So it is if theta varies from 0 to pi by 2, integral sine to the power of n theta into d theta, which is equals to, it is n minus 1 by n minus 3 by n minus 2, and so on, 1 by 2 into pi by 2, if n is even. If n is even, and n minus 1 by n minus 3 by n minus 2, and so on, 2 by 3, if n is odd. Okay, since here n is an even number, therefore the integral value is 8a square n minus 1, n equal to 4, 4 minus 1, 3 by 4, n minus 3, 3 minus 4 minus 1, n minus 3, 4 minus 3 is 1, divided by 4 minus 2, 2, 1 by 2, if we get into pi by 2. Therefore, 4, 2 ja 8, 8 cancel. So, it is 3 pi by 2 into a square. 3 pi by 2 into a square. So, this is the area of the cardioid. This is area of the cardioid. Okay. So, this is the cardioid. Since it is symmetric above the initial line, we'll evaluate, we consider the region only above the initial line, and twice the integral above the initial line, we consider region, we get the area. Okay. So, this is evaluation area in polar coordinates. Let's see volume. Find the volume of the sphere x square plus y square plus z square equals to a square. Find the volume of the sphere x square plus y square plus z square equals to a square. So, let's imagine a sphere. Okay. So, now volume bounded by the sphere, it is x square plus y square plus z square is equals to a square. The volume is bounded by the sphere x square plus y square plus z square equals to a square. Now, see, if you imagine a sphere, of course, it's look like a circle in 2 dimension, but actually, let's imagine a sphere. In case of 2 dimension, it is a circle. Let's imagine a 3-dimensional figure. Okay, so in case of circle, we have it is spread in 4 quadrants, whereas a sphere means it is in 8 octant, which is symmetric about xy plane, yz plane, as well as zx plane. Okay, so that means whatever the volume you have in the first octant, you have the same in all other 7 octants. That means instead of evaluating the volume over the entire sphere, it is better to evaluate the volume in the first octant, get it multiplied by 8, you get the volume of the sphere. So since the volume, since the sphere is symmetric about xy plane, yz plane, and xz plane. So therefore, volume of the sphere is equals to 8 times volume of the sphere in the first octant. That means, therefore, volume V is equals to 8 into, general formula is volume, actually, okay, directly I am writing volume V is equals to, see, here I will write actually the formula. Volume generally is equals to triple integral over the volume. It is dx into dy into dz. Now here it is 8 times the volume V in the first octant. So, volume over the first octant into dx, dy, dz. dx dy dz. So volume, we are considering only the region of integration in the first octant, means all the lower limits are always 0. Remember. That means what are the limits for z now? First, so z limits. Z varies from 0 to z square can be written as a square minus x square minus y square. A square minus x square minus y square. A square minus x square minus y square. Z equals to root over a square minus x square minus y square. Actually, z equals to plus or minus root over a square minus x square minus y square. But we are considering the region in the first octant where all the coordinates x, y, z are positive. So we will consider only positive value, the root over a square minus x square minus y square. Okay. And next, so 3 dimension to coming down to 2 dimension. Okay. So that is 0 to, now let's consider its projection of that region in the xy plane. In the xy plane, you are considering the projection, means xy plane equation is z equals to 0. So z equals to 0, if you substitute in the sphere, it becomes a circle. That is x square plus y square equals to a square. So x square plus y square equals to, in xy plane, the equation is x square plus y square equals to a square. In such case, what is y? Y is equals to plus or minus root over a square minus x square. But remember, we are considering the region only in the first octant. Always x, y, z are positive. So we consider only positive value for y. That is, y is equals to, y varies from 0 to root over a square minus x square. Let's coming down to single integral now. Okay. X varies from. Now coming to x-axis. On x-axis, y equals to 0. That is, x square is equals to only a square, x equals to plus or minus a, but we are considering the region only in the first octant. We consider only positive value for a, x. So therefore x varies from 0 to a. So that means therefore it is 8 into integral x varies from 0 to a, integral y varies from 0 to root over a square minus x square, integral z varies from 0 to root over a square minus x square minus y square. See here, I am writing dz, dy, dx instead of dx, dy, dz. Since here z limits are functions of xy, y limits are functions of x, and x limits are constants. So the order of integration here is first with respect to z, next with respect to y, and finally with respect to x. Let's evaluate. Okay. Now, first with respect to z, no. So therefore, 8 into x varies from 0 to a, and integral y varies from 0 to root over a square minus x square. So integrating with respect to z, so there is no integrand. Integral 1z, 1dz. Integral 1dz is z. Upper limit is root over a square minus x square minus y square. Lower limit 0, dy dx. This is equals to 8. Integral x varies from 0 to a. Integral y varies from 0 to root over a square minus x square. So instead of z, we have to substitute upper limit as well as the lower limit. So what is upper limit here? Root over a square minus x square minus y square. Lower limit is 0. So lower limit has no contribution. So therefore it is a square minus x square minus y square into dy into dx. That is equals to 8 into integral x varies from 0 to a. How to evaluate this integral? Integral y varies from 0 to root over a square minus x square. Observe here, it is in the form of root over a square. See, we are integrating next with respect to y. Next with respect to y. So therefore, we have to treat x as constant. That means, let's write this integral as, it is root over a square minus x square whole square. Observe, this is constant, no? A square minus x square to dy dx. So what is integral a square minus x square? Integral a square minus x square formula. It is x by a. This is equals to x by a. Instead of x here we have y. So it is y by a. What is a? Root over a square minus x square. This is a square minus x square. So if you, I am writing the formula here. So integral root over a square minus x square formula is into dx, which is equals to x by a root over a square minus x square plus a square by 2. It is sine inverse of x by a. This is the formula. See, instead of x we have y. and instead of a we have root over a square minus x square. Just substituting in this formula. See, y x equals to y by a root over a square minus x square into root over a square. A square means this is same. Under root over a square minus x square whole square. I am writing it is root over a square minus x square whole square. A square minus x square plus a square by 2. A square is, what is a square? Root over a square minus x square whole square. Instead of writing that, I am writing directly a square minus x square by 2 into sine inverse of x by a. X by a means y by a. A means root over a square minus x square. Let's substitute the limits. What is upper limit? Upper limit is root over a square minus x square and lower limit is 0. This is equals to 8 into integral x varies from 0 to a. Let's substitute the limits. Upper limit is root over a square minus x square. If you substitute instead of y here root over a square minus x square, what will get? Root over a square minus x square whole square, root over a square minus x square whole square. Same terms with opposite sign, 0, root over 0, 0, 0 into anything 0. So this term completely does not have any contribution. 0. Next here if you substitute, it is a square minus x square by 2, a square minus x square by 2. It is sine inverse of, instead of y if you substitute this, it is sine inverse 1. So root over a square minus x square by root over a square minus x square is 1. Minus substitution of lower limit 0. So instead of y 0, 0 by something 0, 0 into anything 0, no contribution of first term for both upper limit as well as lower limit. Now if you substitute 0 here, it is a square minus x square divided by 2. It is sine inverse of 0. It is sine inverse of 0. Now this is equals to, it is 8 integral x varies from 0 to a. Now let's simplify. It is a square minus x square. Let's write this 2 constant outside and see sine inverse 0 is, 0 can be written as sine 0. Sine inverse cancel, 0, 0 into something 0. No contribution of this term. Only this term we have contribution. A square minus x square into sine inverse of sine pi by 2. Sine inverse of sine pi by 2. 1 can be written as sine pi by 2. Okay, into dx. That is equals to, it is 4 integral x varies from 0 to a. It is a square minus x square into sine inverse sine cancel. So it is pi by 2 into dx. Therefore pi by 2 means this is 2 ja. So 2 pi. Now integral x varies from 0 to a. It is a square minus x square into dx. Let's integrate this with respect to x finally. It is 2 pi. A square integral is a square constant. Integral 1 dx is x. X square integral is x cube by 3. Upper limit is a. Lower limit is 0. So therefore it is equals to 2 pi. Now it is instead of x, a square into a cube minus instead of x, a cube by 3. Lower limit is 0. So 0, 0, no contribution. So it is 2 pi into 3 minus 1. It is 2a cube by 3. That is equal to 2 to 4. So 4 pi by 3 a cube. 4 pi by 3 a cube. As we know the formula, the volume of the sphere is 4 pi by 3 r cube. What is r? R is the radius of the sphere. So here the radius of the sphere is a. That's why the area of the sphere is, volume of the sphere is 4 pi by 3 r cube. Here it is 4 pi by 3 a cube. Okay, I hope you understand. So work out these problems. See, find the area of the plate in the form of a quadrant of the ellipse x square by a square plus y square by b square equals to 1. Okay, and find the area of the Lemniscate of Bernoulli, r square equal to a square into cos 2 theta, and the volume of the tetrahedron x0, y0, z0, x plus y plus z equals to a. So this is the figure. You can understand. You can observe here, and the y limits are, see, remember, z limits are 0 to a minus x minus y, and y limits are 0 to a minus x, x limits are 0 to a, and you can proceed. Okay, so try to work out these problems. Okay, thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.